Chapter 3. Heat. Introduction. Why is it difficult to bathe with cold water in winter? What happens when you rub your hands? What happens when you mix ice with boiling hot water? The answers to all these questions are related to one concept: heat. Heat. We have learnt in previous classes that energy is a capacity to do work. Energy can take various forms. Heat is one of the forms of energy. Different types of energy change into heat. When you rub your hands, they become warm because friction generates heat. When you run or do any other strenuous exercise, heat is generated in your body and you start sweating. Burning of fuels also generates heat. In a water heater, electricity is used to heat up water. Hence, we can see that heat or thermal energy can be produced from different types of energy and it can transform into other types of energy too. At a smaller level, thermal energy is stored in particles of matter. A smaller object will have less heat than a larger object. How is heat measured? Heat is detected by temperature. A cup of tea just made is called hot and it has high temperature. However, water taken from a refrigerator is called cold and it has low temperature. We can define temperature as the degree of hotness or coldness of a body. We generally touch an object and decide whether it is hot or cold. However, we cannot always rely on touch to decide whether an item is hot or cold. Let's perform an activity to understand this. Heat always flows from a body at higher temperature to a body at lower temperature. Units of heat. Heat is measured in units like joule and calorie. SI unit of heat is joule. How is temperature measured? The hotness and coldness of a body can be sensed by touch. However, touching cannot give us a value of temperature. To measure temperature, we need a scale which can measure the degree of hotness of a body as compared to a chosen standard value. Such scales were developed by taking freezing point and boiling point of water as standard values. Scientists have developed 3 scales of temperature: Celsius scale, Fahrenheit scale, Kelvin scale. Celsius scale. This is the most commonly used scale of temperature. This scale was introduced by Swedish physicist, astronomer and engineer Anders Celsius. In this scale, the freezing point of water is taken as 0 and boiling point of water as 100 and the in-between range is divided into 100 equal divisions or units. Each of these units is called a degree. The temperature in Celsius scale is denoted by degree C, degree Celsius. Hence, freezing point of water is equal to 0 degrees Celsius. Boiling point of water is equal to 100 degrees Celsius. One division is equal to 1 degree Celsius. Fahrenheit scale. It was proposed in 1724 by the European physicist Daniel Gabriel Fahrenheit. It was Lord William Thomson Kelvin who discovered Kelvin's scale of temperature. In this scale, the freezing point of water is taken as 32 degrees Fahrenheit and boiling point is fixed at 212 degrees Fahrenheit, and the range is divided into 180 equal divisions. Can you now work out a relation between Celsius and Fahrenheit scale. The Celsius and Fahrenheit scale meet at -40 degree. This means -40 degrees Celsius is equal to -40 degree F. It is the most commonly used in scientific calculations. In this scale, freezing point of water is 273.15 K and boiling point is 373.15 K, and between the two temperatures, there are 100 equal divisions. Thus, one division in Celsius scale is equal to one division in Kelvin scale. Instrument for measuring temperature. Temperature is measured by a thermometer. A thermometer is a device which detects the change in temperature of an object. It works on the principle that liquids expand on heating. When a liquid is heated, its particles move faster and spread out over a larger area. This is called expansion. When a liquid is cooled, its particles slow down and come closer. Hence its volume decreases. This is called contraction. In the beginning, alcohol was used as a liquid in thermometers. Nowadays it is replaced by mercury. A thermometer consists of the following parts. There is a thin glass tube of very small diameter, capillary, with a bulb at one of its ends. The bulb is filled with the liquid and air is removed from the upper part of the capillary and its open end sealed. The capillary is surrounded by a glass tube on which a scale is etched to read the temperature. In an alcohol thermometer, the scale is usually from -10 degrees Celsius to 75 degrees Celsius. In a mercury thermometer, scales can vary up to much higher temperatures. When the bulb of the thermometer comes into contact with an object at higher temperature, the liquid in the bulb expands and rises up in the capillary. The level of the liquid is read on the scale and it gives the temperature reading. Let us learn more about types of thermometers and how to use them. The laboratory thermometer. The thermometers used in laboratory are filled with either alcohol or mercury. The range of a common mercury laboratory thermometer varies from -10 degrees Celsius to 110 degrees Celsius. While using the thermometer, its bulb should be dipped completely into the liquid. When you use a thermometer in the lab, be careful about the following. Never hold the thermometer from its bulb. Keep the thermometer vertical. Dip the bulb completely into the liquid whose temperature you are measuring. The bulb or the stem of the thermometer should not touch the walls or base of the container. Take the temperature reading without moving the thermometer out of the container. While noting the reading, your eyes should be at the same level as the mercury line. Take at least 2 readings to avoid inaccuracy. Before noting the readings, find the least count of the thermometer. Least count of a thermometer is the temperature reading represented by 1 division on its scale. You can calculate the least count of a thermometer in simple steps. Hold the thermometer and count the number of divisions between any two numbers on it. Divide the difference between the numbers by the number of divisions. For example, if there are 20 divisions between 10 degrees Celsius and 20 degrees Celsius, the least count will be 10 upon 20 is equal to 0.5 degrees Celsius. The clinical thermometer. A clinical thermometer is used to measure body temperature by bringing its bulb in contact with the body. Nowadays digital thermometer is also used to measure body temperature. In the above activity 3.3, what was your body temperature? For a normal, healthy person, the body temperature is 37 degrees Celsius or 98.6 degrees Fahrenheit. If the body temperature is higher, a person is said to have fever. Differences between lab and clinical thermometers. Lab thermometer. Clinical thermometer. 1. It is longer than clinical thermometer. 1. It is shorter than lab thermometer. 2. Temperature range is from minus 10 degrees Celsius to 350 degrees Celsius. 2. Temperature range is from 35 degrees Celsius to 42 degrees Celsius. 3. While taking reading, bulb remains in contact with the substance. 3. While taking reading, bulb is moved away from the body. 4. There is no constriction at the base of capillary. 4. There is a constriction at the base of capillary. How is heat transferred? We have read earlier that heat always transfers from a body at higher temperature to a body at lower temperature. This transfer of heat takes place in three ways. These are conduction, convection, and radiation. Conduction. When an elder is making tea at home, dip one end of a metal spoon in hot water and hold the other end in your hand. What happens after a few seconds? The end of spoon in your hand also heats up. This happens because of conduction. The heat passes from hot water to the end of spoon dipped in it, and from there to the end of spoon in your hand. Conduction is a mode of heat transfer in solids. In solids, the particles are closely packed and cannot leave their positions. However, they can vibrate at their own positions. When heat energy is provided to the particles, they start vibrating faster and collide with neighboring particles. During these collisions, heat is transferred from a hotter particle to a colder particle. This process takes place rapidly and continuously till the whole solid heats up. For conduction of heat, a solid should be in contact with a source of heat or another object at higher temperature. Metals are the most common solids which transfer heat through conduction. However, all solids do not allow heat transfer like metals. Some solids allow the heat to transfer very slowly while others do not transfer heat at all. Solids which readily allow the transfer of heat through them are called conductors of heat. Metals like gold, silver, iron and aluminium are conductors of heat. Solids which allow heat to pass through them slowly are called poor conductors of heat. Example: glass. Apart from solids, air and water are also poor conductors of heat. Solids which do not allow heat to pass through them are called non-conductors of heat or insulators. Examples: wood, paper, bakelite, asbestos, clay. Conduction in our lives. Metals such as aluminium, copper and alloys like stainless steel and brass are used to make cooking vessels because they conduct heat quickly. Among metals, silver and copper are very good heat conductors. However, these metals are too expensive to make. Regular utensils. Handles of cooking utensils are made of wood or a plastic called bakelite, as these are insulators of heat. Woolen clothes keep as warm in winter. This is because there is air trapped in the pores of woolen clothes which acts as insulator and does not allow body heat to escape out. In summer, to keep ice from melting, ice slabs are covered with thick jute cloth or sawdust. Jute is an insulator and has air trapped between its fibers. Both of these insulate the heat of the surrounding. Convection. Convection is a mode of transfer of heat in liquids and gases. Convection is based on the principle that hot particles of liquids and gases move faster and rise up, letting the cooler particles to move down towards the source of heat. This causes motion of molecules in a particular direction, which is called convection current. Convection in our lives. The room heaters are kept on the floor in a room. The air near the heater heats up and rises, forcing the cool air to move down, setting up a convection current. In summer, we need air conditioners to cool air. The air conditioners should be placed high up on the wall. This is because the air on top cools and moves down, giving way to the warm air, so that the entire room cools. In a refrigerator, the air gets cooled in the freezer compartment. Cold air moves down and takes the heat from the lower compartments. It gets warmer and again rises up. Winds are caused by convection in air. The air at the equator gets heated by sun and rises up. The cooler air from poles moves towards the equator. This results in huge convection currents which cause winds across oceans and continents. In the coastal areas, wind blows all the time. During daytime, the land gets heated up more quickly than the sea. The air over the land gets heated up and rises. The cooler air above the sea water moves towards the land. This is called sea breeze. At night, the land gets cooler faster than the water in the sea. The air above sea water is warmer and rises up. The cooler air above the land moves towards the sea. This is called land breeze. Radiation. Have you ever wondered how the sun makes you warm? The energy of the sun reaches us in the form of waves. These waves are absorbed by all matter. The heat energy from the sun is transferred by a type of waves called infrared waves. When a body absorbs infrared waves, it heats up. This type of transfer of energy is called radiation. Unlike conduction and convection, radiation does not need a substance or particles to transfer energy. Radiations can travel through vacuum. In other words, conduction and convection need a medium to transfer heat, but radiation does not need a medium to travel. Understand that the sun is not the only body to give out heat energy in the form of radiations. All hot bodies give out infrared radiation, heat, solid, liquid gas, vacuum, conduction, convection, radiation. In the above activity, we see that a black surface is a better absorber of heat than a white or silvery surface. In fact, black and non-shiny surfaces are best absorbers and best emitters of heat. White and silver, shiny surfaces reflect most of the heat. They are poor absorbers and poor emitters. Radiation in our life. We get heat from sun in the form of infrared radiations. The carbon dioxide in air absorbs the infrared radiations reflected by the earth and heats up. This is called the greenhouse effect, and it keeps the earth warm. Surfaces of room heaters are silver and shiny to reflect most of the heat to the air. We wear dark-colored clothes in winter to absorb maximum heat and light-colored clothes in summer to reflect maximum heat. Solar heaters and solar cookers absorb the infrared radiations of sun to heat substances. What is expansion? We have already learned that when particles of matter absorb heat energy, they start moving faster. When they move fast, they spread out. This increases the space between particles, thus increasing their volume. This is called expansion. Expansion takes place in solids, liquids and gases. We can say that when an object gets heated, it expands, and when it cools, it contracts. Expansion is minimum in solids and maximum in gases. Can you discuss why this is so? Expansion in our lives. Railway tracks have small gaps at regular intervals. In summer, the metal expands by absorbing heat. So the length of the track increases. If the gaps are not there, the track will bump up and cause accident. Similarly, gaps are left between the concrete and steel bridges. In summer, the bridges become longer due to expansion, and in winter, they contract. Electric wires sag down in summer due to expansion. If you pour boiling water in a container made of thick glass, it cracks. This is because the inner surface expands, but the outer surface doesn't. A bimetallic strip contains two metal strips joined together. One strip is of brass and other of iron. When the strip is heated, both the strips expand. Brass expands more than iron. As a result, the strip bends. A bimetallic strip is used in electrical devices like fire alarm and thermostats. In a fire alarm, the bimetallic strip remains straight at normal temperature. In a fire, the strip gets hot and bends. It touches the connector attached to the bell, and the circuit gets completed. This makes the bell ring. In a nutshell, heat is a form of energy. Heat is measured in terms of temperature. A hotter body has higher temperature than a colder body. Temperature is measured by a device called thermometer. Body temperature is measured by a clinical thermometer. Temperature can be measured in 3 different scales. These are Celsius scale, Fahrenheit scale and Kelvin scale. The basic unit of temperature is a degree. Materials which allow heat to pass through them are called conductors of heat. Materials which do not allow heat to pass through them are called insulators. Heat is transferred in solids by conduction. Heat is transferred in liquids and gases by convection. When a body absorbs infrared waves, it heats up. This type of transfer of energy is called radiation. Conduction and convection need a medium to transfer heat, but radiation does not need a medium to travel. All hot bodies give out radiations called infrared radiations. Infrared radiations do not need a medium to travel and can be absorbed by all objects. A black surface is the best emitter as well as absorber of heat. Heat causes expansion in all matter. Expansion is minimum in solids and maximum in gases.